Welcome to this explainer. Today, we're going to completely transform how you view AI. Seriously, we're moving way past the days of simple, forgetful chatbots, and we're stepping right into the world of robust, autonomous systems that can actually run your most complex enterprise infrastructure. If you've been struggling, and let's be honest, who hasn't, to get AI to reliably handle complex, multi-step engineering tasks, well, you're in exactly the right place. Okay, here's our roadmap for today. We're going to cover the AI amnesia problem, context versus tokens, the three-agent harness, enterprise infrastructure as code, self-healing pipelines, and finally, wrap up with the future of AI agents. Let's get right into it. So, starting off with Section 1, the AI amnesia problem, or, forgetting crucial steps. Look, we all know the absolute pain of dumping massive amounts of code into a language model, right? Only to watch it completely hallucinate, lose the plot entirely, or, my personal favorite, forget a crucial instruction it literally just agreed to like 5 minutes ago. And that brings us to the 1 million token wall. For the longest time, the industry narrative was just, hey, build a bigger context window. But recent data, it's been a major mythbuster. You just can't dump a 500-file repository into a massive context window and expect it to magically work out. Check out this insight from the maintainer of SWE Rebench. They point out that models hit a clear performance ceiling around 1 million tokens. Just giving an AI a massive context window doesn't automatically mean better performance. Actually, scratch that, it's worse. Injecting more noise actively degrades the output. The model's ability to focus on the right information basically plummets as that token count climbs unnecessarily high. Every wasted token isn't just wasted money, it is literally degrading the intelligence of your agent. Moving on to Section 2, context versus tokens. Engineering the prompt. All right, this is where we need to completely shift our mindset. We're moving from brute-forcing tokens to, well, surgically engineering them. Martin Fowler perfectly captures this whole idea. He explains that prompt engineering focuses on how you phrase the input for a single interaction, which is great for one-off requests. But context engineering? That's about curating exactly what information the model sees over a long, multi-turn session. Context, not phrasing, is the real bottleneck for coding agents right now. Think about it. If your agent can't access the right files at the right time, the most cleverly phrased prompt in the world is going to be entirely useless. Because of this, the industry is standardizing on solutions like the CLAUDE.md playbook. By creating hierarchical context files, at the root, subdirectory, and user levels, you basically establish a system where the AI only lazy loads the exact context it needs for a specific module. By treating context files like essential infrastructure rather than just some optional configuration, you slash your context size by 95%. This incredibly lean approach means you're using 5.5 times fewer tokens than environments like Cursor. We're talking about saving hundreds of dollars on API costs, all while drastically reducing those annoying hallucinations. It's a total win-win. Which leads us to Section 3, the three-agent harness, focusing on multi-agent workflows. Okay, so once the AI actually has that perfect, lean context, how do we stop it from forgetting everything during an intense 4-hour coding session? Well, the engineering team at Anthropic actually cracked this. They built a structured multi-agent workflow. So instead of one massive session that slowly degrades into total amnesia, they divide the work up among distinct agents. One for planning, one for generation, and one for evaluation. They rely on clean handoff artifacts like JSON feature specs and complete context resets between stages to beat that AI amnesia step by step. As Prithvi Rajasekaran, an engineering lead at Anthropic Labs, points out, separating the agent doing the work from the agent judging it is a massively strong lever here. Because let's be real, language models are notoriously bad at grading their own homework. They almost always overrate their own subjective work. But by bringing in an independent evaluator agent, one that can actually navigate live pages and interact with interfaces using tools like Playwright MCC, you force the generating agent into these iterative refinement cycles. And these cycles are based on hard, objective critiques, not just self-congratulatory hallucinations. All right, let's jump into Section 4, Enterprise IAC, or Intent-Driven Automation. It is time to take all these high-level architectural concepts we've been talking about, the context engineering, the multi-agent harnesses, and deploy them into a concrete, high-stakes enterprise environment. What you're looking at is the AI-Assisted Configuration Management Framework, or AICMF for short. It's a layered architecture showing exactly how natural language intents, like say ensure all web servers enforce secure SSH, are processed into fully validated server configurations. It is literally an end-to-end pipeline that goes from a simple intent form through an AI generation engine into strict semantic validation, human approval, and finally right into a Git-based CI/CD deployment. And the horsepower running under the hood here, it's staggering. The core engine uses a 34 billion parameter Code Llama 3 base model, which has been fine-tuned on 48,000 annotated playbooks. But here's the real secret sauce. It uses retrieval augmented generation. It pulls from a ChromaDB vector database to inject organization-specific policy constraints directly into the prompt. So it doesn't just guess your security policy, it actually retrieves it. This multi-stage semantic validation completely eliminates hallucinations, ensuring syntactically flawless, policy-compliant Ansible and Puppet playbooks before a human ever even lays eyes on them. Moving right along to Section 5, Self-Healing, Fixing Drift on the Fly. Deploying perfect code is great and all, but what happens when some rogue manual change causes a server's live state to just drift completely away from the baseline? Well, look at this hard data from a 1,000-node heterogeneous Linux testbed. You can see the system polling agent reported system states and detecting anomalies using an isolation forest model. And get this, it detects configuration drift in a median time of just 47 seconds, with an incredibly low 3.8% false positive rate. It actually knows the difference between a routine package update and a legitimately dangerous security divergence. And the impact of automatically generating a targeted remediation playbook on the fly, it's absolutely staggering. We are talking about an incredible 78.6% drop in mean time to remediate. To put that into perspective, what used to take human engineers 4.2 hours of manual investigation and playbook writing now plummets to just 54 minutes. That is a game changer. But wait, it gets even better. Because the system relies on that strict context engineering and those fine-tuned models we talked about, the framework maintains an amazing 94.3% playbook accuracy rate. It easily handles highly complex multi-role configurations across RHEL, Ubuntu, and CentOS without even breaking a sweat. It ensures over 91% adherence to strict CIS Level 2 benchmark compliance. Now, the absolutely crucial point here is safety. This isn't about just letting AI run wild with root access, no way. It automates the repetitive, boring toil, but heavily uses tiered, risk-proportionate approval gates. Low-severity drift, that gets auto-approved and fixed. But higher critical severity, the system immediately pages a site reliability engineer via PagerDuty with the exact generated playbook for review. During a 12-week test, out of 1,847 drift events, almost 88% were resolved entirely automatically. So it does the heavy lifting while keeping humans fully in control of the high-stakes decisions. And finally, Section 6, the future of AI agents, looking at autonomous operations. You see, these frameworks aren't just some neat parlor trick for Linux servers. They represent a fundamental shift in how we govern all technical operations. We are seeing these exact same principles applied all across the tech stack. Whether you're doing context-aware SQL generation, automated schema validation, or proactive data anomaly detection, these structured setups provide massive efficiency leaps. By utilizing systematic prompt engineering and multi-agent validation chains, you can routinely cut development time for common data pipeline activities by up to 60%. So as we wrap up this explainer, I really want you to think about your current workflows. Are your AI agents acting as simple chatbots? Are you just throwing more tokens at the wall and hoping the AI remembers the plot? Or are you stepping up to true autonomous execution by engineering the context, building multi-agent harnesses, and letting AI actively heal your infrastructure? The tools are here. It's time to cure AI amnesia for good. Thanks so much for joining me, and I'll see you in the next one.